We've moved past the point where typing a prompt yields a simple text response. Today, we use those same inputs to manage integrated software systems. Over the next 6 minutes, we are going to engineer a fully customized, highly polished prompt and knowledge library application. To achieve this, we will rely on 3 core mechanisms: synthesizing the UI visually, offloading the project management, and executing automated quality assurance. By moving the AI into a self-managing role, a single person can now oversee every stage of production simultaneously. Step 1 is preparing our digital environment. You need to have the Codex desktop application open and your project workspace connected. Before writing a single command, navigate to your settings and explicitly turn on computer use, along with granting the agent full access. Without these permissions, the automated processes will fail. It is tempting to max out the settings and choose the highest intelligence tier. However, for this workflow, you should set the model to medium. Medium gives us optimal token efficiency. Instead of burning computing power overthinking basic structural requests, it draws a direct line to your intent, completing standard operations faster and at a fraction of the cost. By rigorously calibrating these parameters right at the start, we ensure the agent has exactly the permissions and efficiency it needs to avoid bottlenecking its own execution later. With the environment set, we begin our first operational phase. Rather than writing code immediately, we instruct the model to generate the application's layout visually. We prompt the system to design 4 or 5 interface options for our prompt library, specifically requesting a clean, simple, and card-based design aesthetic. The system instantly returns 5 distinct, high-fidelity layouts that match our parameters. From this grid, we evaluate the options and isolate the one that best serves our workflow. In this case, the option featuring clear visual cards and green accents. We then instruct Codex to use that specific visual mockup as its exact development blueprint and compile the underlying codebase to match. Generating the interface visually first completely bypasses the traditional wireframing phase. It allows us to translate a visual aesthetic directly into functional software in a single step. Once the code compiles, we can view the results in the live browser preview space, which renders the software into an interactive interface. To make adjustments, we use the Annotate tool. Instead of digging into code, we simply draw a boundary directly over the interface. Inside, we type an instruction to add a favorites function. The system instantly inserts a new button perfectly into that location. Pointing to exactly where you want a feature to go on screen is exponentially faster than trying to describe that spatial relationship through pure text commands. Now that the core interface is built, we shift our focus from granular coding to high-level project management by opening a second, parallel chat window. We connect Codex to our linear project board and instruct this secondary agent to outline and organize all future development tasks for the application. The agent independently analyzes the codebase we just generated and categorizes individual tickets for UI polish, database architecture, and upcoming features. Within seconds, the project board auto-populates with categorized task cards, priority tags, and detailed briefs. With the roadmap established, we can now spin up multiple AI agents simultaneously and point them at the project board, instructing them to work through the ticket side by side. Integrating this second brain framework moves the AI out of the role of a passive coding assistant and turns it into an active, autonomous product manager. The final requirement is verifying that the prompt library actually works. Instead of manually clicking through the app ourselves, we deploy the agent to run its own quality assurance cycle. We give the system a single command to use its computer control capabilities to test all the features we just built. The system cursor seizes control of the environment, navigating autonomously across the screen to initiate the testing sequence. Without any human input, the agent clicks the Favorites button, creates sample text entries, and verifies data processes correctly. Having the system perform its own validation successfully closes the development loop. It removes the final human bottleneck from the deployment process. In just a few minutes, we have synthesized a layout, compiled a functional application, populated a project pipeline, and completed a full QA cycle. Manual coding is being replaced by a process of engineering autonomous workflows. As digital tools evolve into fully autonomous systems, future success depends on the seamless coordination of these digital ecosystems.